Now let's talk about the covalent compounds and what exactly is the structure of covalent compounds. If you recall, when we talked about ionic compounds, we said that ionic compounds are crystals. So if we have Na1 plus charge, it's not just surrounded by one Cl minus, it's surrounded by 6 Cl minus on each side, left, right, up, down, front, and back. Similarly, each Cl minus is surrounded by many sodiums. And the ratio in this crystal is for one Na we have 1 Cl, and so we give it the formula NaCl. The reason why when we come across a ionic compound where we crisscross the charges, for example barium sulfate, or some other example barium oxide, Ba has 2 plus charge and oxygen has 2 minus. After we crisscross them, we get Ba2O2, but we don't write it as Ba2O2, we write it as BaO, barium oxide. Why? Because it's the ratio. It's not as if there are just two bariums for two oxygens or one barium for one oxygen. We just take the simplest whole number ratio. And that's the reality about ionic compounds. But compared to that, covalent compounds are actual molecules. They are discrete molecules, as it says here in the slide. They exist in the ratio we give them. One example of a covalent compound is water. Water has the formula H2O, where we have two hydrogens and one oxygen. That does not mean that the ratio is 2 to 1, but there are billions of hydrogen and billions of oxygen, otherwise no. There is actually a discrete unit which we call a molecule, and that has the formula H2O. And because of that, when we name covalent compounds, we are actually going to specify how many of each kind of atom we have. When we had a compound made of ionic ions such as magnesium and chlorine, which gives us the formula MgCl2, we called it magnesium chloride. We did not specify that there were two chlorines, we just called it magnesium chloride. But when a compound is made up of just covalent, when a compound is covalent compound made up by sharing of electrons, it's a discrete molecule. And if it ends with 2 or 3 or 4 or any of the other total number of atoms for a given atom, then we need to specify with these Greek prefixes: mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. And we need to do that every time whenever we have a compound that's covalent. There is one slight exception. When the first atom in a molecule that's covalent is just one single atom, we don't specify that as mono. We just give it its name. For example, what's the name of this unit, this molecule CO? It's called carbon monoxide because there is one oxygen. But wait a minute, isn't there one carbon too? Yes, but that's where we apply this exception and we do not specify how many carbons it is, as long as it's one. If it is more than one, yes. And all the other rules that we apply to ionic compounds are in effect. The first atom is just given the same name as it actually has, while the second atom is given the suffix IDE that we learned about in when we are naming ionic compounds. And so here are some examples of covalent compounds. How do I know they are covalent? You need to verify whether a compound is ionic or covalent the first thing you do when you look at its formula. How do I know this is covalent? The reason I know it's covalent is because the atoms involved are both non-metals. So you need to do that check first before you try to name them. Now that we know they are covalent, we will name them where we'll take the number of units of each kind of atom into account. Pause your video and write down the names of these 4 compounds, and then let's look at the names now. So this is silicon, this is oxygen, but we have two of these. So we call this silicon dioxide. Silicon dioxide. What about this? Well, we have two nitrogens, so we have to specify that in the name, and five oxygens. This is called dinitrogen pentoxide. Dinitrogen pentoxide. This is called carbon tetrachloride, and this is called iodine heptafluoride. That's how we name covalent compounds. And if you are given the names, you should if you are given the names, you should be able to come up with the formula, which is also very straightforward. Nitrogen trichloride is nitrogen with 3 chlorines. Diphosphorus pentoxide is 2 phosphorus with 5 oxygens. Okay. Now, when it comes to covalent compounds, there are a lot of them which have common names. Historically, they had common names, and we all know water has existed since humanity walked on earth, and we had given it a non-chemical name in all cultures. In English, we call it water, and so we don't specify this with a scientific name. But if we were to, what would we call this? We would call this dihydrogen oxide. Then this molecule is also very common. We call it ammonia. What would be the scientific name if we were to call it by that? Would be nitrogen trihydride. Now there are other complex ones where we cannot apply that logic. Usually the system we have used so far of naming compounds for naming covalent compounds works for binary compounds, which are compounds made of two different atoms. We have more than two, as in what you see here. They usually have some common name or some other method of being named. This is ethanol, also called ethyl alcohol, which is the drinking alcohol. This is C6H12O6 is glucose. Okay, so give the formulas of these 4 covalent compounds. Nitrogen monoxide. Pause your video and write down the answers to all 4. The first one is NO, both uppercase. The second one is N2O4. Third one is P2O5, and the last one is NF3. And that's how we name covalent compounds.